Welcome, I am John Lira, and I want to give you a short presentation and demonstration on external matching using the Informatica Master Data Management Multi-Domain Edition of the product. Now, I have this presentation, but I'm only going to go through a few slides and then quickly go into the product and demonstrate this. Now, I do have this presentation in which I review regular matching within the hub. I define matching, but I want to focus on external matching. Essentially, there's a couple slides that I want to focus on, and one of them is the why. Why external matching? There is a reason and there is a need. It is a business need, but it's also a trial and testing need. So you may want to match a list of records against records already in your hub without loading those match list records into your base objects. For example, you can read every item on your own, but for example, it's for match rule tuning. When you're developing the rules, you might want to test them out. Also, you might have an external reference or lookup table that you want to match against. So there's a lot of good reasons why you want to match from an external list into your hub and save the results externally, not in the hub. So that's what we're trying to get at. And again, I'm not going to review every slide. I just want to focus on external matching, and here it is. So we're focusing on this. Notice that we have an external input table that will contain those values that we want to match against, and external output table that will output those candidates that were matched, giving you a match pair table. So the input, the records that are sort of quote clean, or the list of matchable records. The hub contains the list of candidates that I want to match. And external match jobs can process both fuzzy and exact match rules. You can also use fuzzy match or exact match based objects. So it does assume that you know how to do matching already within the hub, and we're just focusing on one of the attributes. So let me go back into, I skipped a few slides. Let's go into the external matching components. So there is a based object EMI. That's the input table containing the rows to match, and the output table, EMO, of the based object containing the match candidates. And again, the EMO will be a match pair produced by the hub as it matches. So let me skip a lot of the complexity. Pretty much that's it. There's some restrictions, some requirements, etc., but I can demonstrate those. So let me go into the hub, and the first thing I want to do, I'm going to create a dummy based object. Let me just call it demo. Notice I'll just call it demo. Not very creative, but here is a brand new based object called demo. And of course, I would have to configure it, the columns, match rules, whatever I want. But I just want to show you what it looks like. So there it is, demo. I'm going to go to the Oracle database where I have this repository stored. I am using the TRN workshop. Let me refresh to make sure that that based object that I created shows up. And if you look at it, I am looking for demo, and here it is. So there goes the based object demo that I created. Of course, I didn't add columns. I didn't really do much to it. I'm just trying to demo the structure. And notice that it has a bunch of tables that belong to the based object. The one that we're going to focus on is the EMI, the based object external match input list, and the output EMO. Now there's another tables that will come in handy, the match tables and the STRP that we reference in contrast to regular matching, but that's pretty much it. I just wanted to show you there. Notice the EMI. The input table has 3 columns defined by the hub. The source key, source name, and file name. These are to be used to create a composite key so that you know where this record came from when we have matched it. You don't have to fill in all 3 values for each record. I could just use source name or file name. I'll show you how I did it. But again, every record inserted into this table must be unique. Now the EMO table also has some predefined columns. Again, the source key, source name, and file name. Notice those look similar to the input table. Well, this is how we can go backwards and see where it came from. And then the rest signify the match pair data. So that's the structure. Let me go back into the hub now, and let me walk you through buyer. I have already configured buyer. So you create another based objects just like you normally do. In the buyer, you create its columns. Notice that this based object has something called buyer ID, full name, contact name, first, middle, last name, and address, and a zip code. Again, this is just a demonstration, so this is very simplistic. Contact info and address information. Now, you need to configure this and go through the appropriate match rules. And in this case, I'm matching exact. Notice that in the presentation, I indicate that we could also do fuzzy. But because this is a very quick demo, I've chosen exact. And I have no paths, but I do have match columns. So the match column will be full name. So first name, middle name, and last name in my mapping were concatenated to produce full name. And that's what I want to match. And so then I go to my match rule set. I have a match rule set called W1, which is my default. And I have a rule. The rule called full name. Notice under auto is no, which means don't automatically merge. Again, these are details that you should be familiar with already. And essentially, my matching will be based on full name. So my key is full name, and my matching level, search level, is also full name. If you take the entire 4-day hub class, you will learn how to structure and configure this fully. And that's it. That's for my matching. Now, I also have staging tables. That belongs to the based object. Remember, a staging table brings data from the landing into the staging. And so I consider the staging to be a subset of the based object. Full name, first name, middle, buyer ID, and then the contact information. So now that I have this, I also have a landing table. This is the landing table that comes from the external source. Buyer ID, full name, middle name, last name. Notice there's no full name. Well, I do that in the mapping. So recall what a mapping is. It is a diagram that takes data from the landing, does any transformation logic, and outputs it. So what I'm doing here, the landing buyer data, some columns are going to be trimmed, made uppercase, concatenated, and then stored in the staging table. Nothing different than how you would normally create based objects. All that is exactly the same way. So now, of course, you had to set your trust, etc., and all that. So that completes it. Now, where does the external matching comes in? Well, you'll see that I've already set up my matching. Let me go back to the hub, to the Oracle, and I'm going to look at buyer. First of all, I want to show you what my data looks like. So this is just a demo. So what I've decided to do is just do it through a script here. We have to delete the records from the landing table. And then all I'm inserting are 3 records. Notice I have record 100, Fred A. Smith, and his address. In this case, it's mixed case, lowercase, and then uppercase S. I'm going to put another record called Fred A. Smith. It sounds like a duplicate record. The address is the same. And then a third record called Fred A. Smith with a Y instead of an I. So these are the records that I'm inserting. This part here is to insert my data into my landing table. Then I run the staging table, and then that's how that data gets into the staging. Fine. Notice we have to, from a process point of view, you got to land the data, stage the data, and load the data. And so once it's loaded, now I focus on, before matching, the EMI table. Notice the 3 columns that are mandatory: the source key, source name, and found name. Now, how do you get your matching data into here? You get your data however way you want to insert it. I just created a column called full name, and I enter the data. If you happen to use Power Center, you can write a mapping to do the ETL. Extract, transform, and load the data into this table. So you can do it through a SQL loader. You can do whatever you need. I simply, for this demo, enter the column and then enter the data directly. Now, if I were using fuzzy logic, the hub would have also entered the match columns in here. But I'm not. I'm using exact. And let's take a look at the data. So the input data, my list, this is just a sample one, an input table consisting of 1 record. Notice the source key is 1. Fred 1 is the source name. Anything that makes this record unique, if I really had thousands and thousands of records. These 3 must generate a unique key. And not each one has to be filled in. Now, what's my data that I'm going to match? Something called Fred space A space Smith, uppercase. It is case sensitive. Since I'm doing exact matching, case must also be taken into account, right? Lowercase is not the same as an uppercase value. So that's my input table. Then I go back to the hub, and it's quite easy. You go back to batch viewer, and you go to where it says external match. And as soon as I do this, you have the external batch job for buyer and demo, but I'm working on buyer, and you just execute it. Now, I've already done that, so let's check it out. Notice it says total records 1. It matches against 2 records. Q for manual merge are 2. Is that true? Yes, I had 3 Fred Smiths, and so those 3 got into the hub, and 2 of those records have been determined to match against my input. So I have those 3 records. Let's take a look at them. I have buyer, and here are my 3 records that made it to the based object. Notice they're all Fred Smith, except for one is with a Y. My input table, EMI table, is matching against the first 2 records. And notice the record names, record numbers, record 1 and 2. Okay, row ID object 1 and 2. So after I run that, let's see what the EMO table, the buyer EMO table. First of all, the first 3 columns are the key, and look what it says, the match pair. Row ID object 2, using rule 1, matches, and row ID. So I have 2 records that are matched with the input table, and if I keep going, you see the row ID, the match rule, and the creator and the date. So 2 records were matched. Let me go to the hub, and again, look at the consolidation indicator. That does not change. When you're using external matching, it is not touching the consolidated indicator. And that's it. So now I know what my match pairs are. Here it is, 2 records. And in fact, that is true. That is what was matched. Record 1 matched record number 2. Record 1 matched record number 1. And that's pretty much it to my matching. Now let me extend this. That's all there is. Of course, in a real example, your input table will be much larger. You would need to maintain that. And then your matching candidate records will be bigger. So that solves that problem. Why would I want to do this? Maybe for testing the rules. Or it could be for other business reasons. But let me assume it's for testing my rules. So now that I know that my rules are working, I go back to the based object, and perhaps I want to keep playing with the rules, adding more rules, and make them auto merge, etc. How do I now tell the hub, don't do external matching, but go back to regular matching? Well, we go back to the batch viewer, and in this case, I will delete the external match job. And now I go ahead and perform the classic way of doing it, which is manual match or manual match and merge. So let me run this, and again, that sort of concludes the demo. I'm just trying to show that in this case, I would let it run, and I would just end with that this is how you can then go back from external to the regular matching. Okay, let's see. And that concludes this demo. Okay, now what are the weaknesses of my demo? I did not consider fuzzy logic, but again, once you get the hang of it, you'll be able to include that in the rules. Okay, so thank you very much, and again, that concludes my discussion on the external match.